reference to the summary sheet that you see over here. I'm going to make reference to the compound angles and double angles. And remember, I'm going to point out when a question involves both grade 11 and grade 12 work. Okay, so for your questions over here, I just want to indicate that all of this is actually grade 12 in the NSC, although some schools may do it in grade 11 as well. Okay, all of this that you see on this page are all relevant to grade 11 work. And remember, you may be tested on the same work in grade 12. Okay, so let's look at our first example of a prove left-hand side equals right-hand side identity. I've got 2 sine 90 plus theta. Okay, multiplied by cos of negative theta. Okay, all over that whole thing divided by cos of 180 minus theta is minus cos of 360 minus theta. Sorry, there's a plus in between here. Minus cos of 360 minus theta. Okay, so I'm only going to do 1 or 2 examples where I go into detail with what it looks like. Okay, so we need to simplify this. And now the trick to doing this is to look at each of the ratios and the arguments or the inputs individually. So when I simplify this, I'm going to go into the next line. I'm going to put that down there. I'm going to say the 2 remains a 2. And now I'm going to look at this piece over here, sine of 90 plus theta, right? I'm interested in this over here, sine of 90 plus theta. How do I simplify that? Well, if I look at this, I see that I've got negative theta, I've got 360 minus theta, 180 minus theta. Clearly, 360 minus theta is part of the reduction formulae, 180 minus theta is also part of the reduction formulae. Negative theta is not here, okay? So that's something we're going to deal with. But 90 plus theta happens to be a coratio. So I'm going to give you a quick rule. When we deal with coratios, we use coratios when we see it, right? When it's obvious, okay? It's either an acute coratio, for example, sine 20 and cos 70, or it's something that I see like this, and then I have to apply the coratio rule. So how do I simplify sine 90 plus theta? Sine of 90 plus theta. Firstly, I need to identify, according to my summary sheet, that 90 plus theta is part of a coratio. So I apply the rules for coratio. Number 1, the first rule is identify the quadrant, right? And rule number 2 is then apply the coratio, right? Using the sign of the original. Okay, so 90 plus theta is in the second quadrant once I've identified it. Okay, and then sine in the second quadrant is positive. Now I apply the coratio of sine, and the coratio of sine then becomes cos. And I take the complete theta that I see over there, right? So this will become cos of theta. So let's go back to our example over there. This that I see here is sine of 90 plus theta. That is actually going to be cos, positive cos of theta, right? Okay, now I say plus cos of negative theta. Now, if you've done the critical exam revision series already with me, remember there's one of the rules that I speak of. I say never ever work with a negative angle. I say when you get a negative angle, for example, cos of negative theta, that's not something we want to work with, right? Just to standardize things, we always say let's add plus 360. And if I add 360 to that, I get cos of 360, my positive 360 minus theta. And that now looks like a reduction formula, right? That then looks like reduction. Okay, so when I see the reduction formulae, I then apply the rules for reduction formulae, which is very simple. I say identify the quadrant. In which quadrant is this? This thing occurs, 360 minus theta occurs in the fourth quadrant. And in the fourth quadrant, I observe that cos is positive, so it's positive cos. And then I just take the argument that I see over there, theta, and I put it in positive cos of theta. Okay? So the second one here is going to be plus cos of theta, right? Because I added 360 minus and then I applied the reduction formula. Okay, let's go to the ones below. Cos of 180 minus theta. So firstly, identify the quadrant. Cos of 180 minus theta. In my ASTC diagram, 180 minus occurs over here, which means that's the second quadrant. Cos in the second quadrant, is it positive or negative? According to this diagram, cos is only positive in the fourth quadrant. So now I say that this is actually equal to negative cos. And I take the theta there, negative cos theta. Okay, so let's go back. This one below becomes negative cos of theta. Okay, now this minus, that minus is actually just part of the sum. Okay, and now I have to go and simplify this thing over here. Cos of 360 minus theta. So, cos 360 minus theta, oops. Okay, I'm sorry, the eraser is not working. Let's just 360 minus theta. Now let's identify where does 360 minus theta lie. Well, 360 minus theta is in the fourth quadrant, right? So in the fourth quadrant, my cos has to be positive. Positive cos, and I just take theta, and that's what I'm going to get, right? So positive, negative multiplied by positive cos of theta. Now I can simplify very easily. I can say that, okay, I've got 2 cos theta plus another cos theta. That's going to give me 3 cos of theta, all over negative cos theta, so that's negative 2 cos theta. Now remember, since the top is factorized, I've got cos theta and cos theta, that cancels with that, and then I'm left with negative 3 over 2. And that has now been simplified. Okay, that's